Hey students, in this video you're going to answer this question where it's just asking you to identify what type of solutions you're going to have. So let's just quickly review about what that looks like. In general, you just want to picture a parabola either touching 2 times on the x-axis, touching 1 time on the x-axis, or not touching at all. So 2 real solutions are given here, 1 real solution is given there, and most likely when it looks like this is 2 imaginary solutions given. So let's just check if we graph this, what it's going to look like. Once again, based on the previous methods, that is a method, just quickly graphing it. And we're going to have x squared minus 2x plus 11. You wrote 1, so let me type 11. There you go. It's not showing, so let's go ahead and zoom out. And it's definitely there, it's just floating. So most likely we're talking about this situation right here, where it's going to have the 2 imaginary solutions. Let's just do the math behind it just to make sure that it is 2. So we start by checking, or actually we should have checked that it's in standard form before graphing, and it is. So now we do the A, B, and C. A will be an imaginary 1, so it's just 1. B is -2, and C is 11. For the formula, we're going to use negative b plus or minus the square root b squared minus 4ac over 2a. So from there, we substitute our values. We're going to have -2 plus or minus b squared, so -2 squared, minus 4 times a, which is 1, and times c, which is 11, over 2a. So 2 times 1. From here, we're going to once again check our discriminant, which is the part, the b squared minus 4ac. And we're going to quickly do that in the calculator. So we're going to have -2 squared minus 4 times 1 times 11. That gives you -40. So we're going to have -40 in here. We're going to simplify this other part. So negative times negative is positive. 2 times 1 is 2. And then from here, we're going to look at the -40. And once again, remember that that negative comes out of the square root as I. So now we're looking at having this notation. And then if we check in the calculator the square root of 40, it gives you a decimal, which means that we will prefer to simplify this by hand and think of perfect squares. And the list goes on. But definitely 4 is a factor, so we're going to use 4 times 10. And then now we do square root of 4, square root of 10. Square root of 4 is going to give you the 2. And again, the 2 is the answer from square root of 4 because 2 times 2 is 4. So it comes out of the square root notation, the radical, as a 2. And then we're left with 10 on the inside. So that means that now we're going to have on the outside a 2 along with the I. So we're going to have 2i square root of 10 plus or minus 2 over 2. And then from here, some students were asking, what about the 10? Do we keep going or do we simplify? Well, if you do keep going, you're only going to have 2 times 5 as your options of factors. And 2 times 5, they're not the same number, so they can knock them out. And then pretty much you just put them back together, so it gives you 10. So it goes back to this notation. And then the last step is to check that these numbers right here can be simplified. If not, you're done. They can all be simplified by 2. So if we divide 2 by 2, we're going to get a 1. If we divide this other 2 by 2, we're going to get another 1. And then if we divide the bottom 2 by 2, we get another 1. So let's keep cleaning it up a little bit more. Anytime we divide by 1, it's the same thing, so we don't need this. And anytime you have 1 as a coefficient, you don't need to write it because you just know 1 is there. So technically, the answer here will be 1 plus or minus I squared root of 10. But I wanted to just show you the whole steps in this video just for practice. If we go back to the question was just simply asking what type of answers we have. So this math that we did confirms that we will have two imaginary solutions. One will be the 1 plus I squared root of 10, and the other one will be 1 minus I squared root of 10. So two imaginary solutions. Okay, hope this video helps.